Okay, Big Bang Theory, small scale investigation, all right? According to the Big Bang Theory, almost all galaxies are moving outward from all other galaxies. You can demonstrate the principles of this expansion with a simple model, all right? So the Big Bang Theory, the theory of the formation of the universe, is a theory that we are looking into in our Earth Science classroom, okay? So this is a small-scale investigation that is intended to demonstrate the rate of expansion that galaxies experience from each other. So please pan back. Okay, the procedures, when you're doing this on your own or in your classroom, you're going to want to read all 6 steps below before you perform this investigation. After you have read the steps, then you can begin performing the investigation. Be sure to record necessary measurements of time and distance with units, okay? So the first step that we're going to do today is we're going to take our universe here, which is a balloon, and we're going to mark 3 dots on the balloon, okay? So the first set of dots, it says here, mark a pair of dots a ½ centimeter apart across the middle of the uninflated balloon. Label them A and B. Mark a third dot 5 centimeters away from B. Label this dot C, okay? So I'm going to put my balloon down. It's often good to have 2 people do this so that you can get an accurate placement of your dots. So I'm going to put my ruler here. You got a good shot of that?
Mm-hmm.
All right. So my first dot will go at the 0. It will be dot A. The second dot will go at ½ centimeter to the right. This will be dot B. And then I will place my third dot 5 centimeters away from dot B, which will be here. This will be dot C. Okay, so there are our 3 dots. A little bit tough to see all 3 at once on the balloon. Okay, all right. Step 2, blow into the balloon for 2 to 3 seconds. Record your elapsed time below. Pinch the balloon between your fingers to keep it inflated, but do not tie the neck, okay? So Michael, if you will count to 3 when I start blowing, 1 1000, 2 1000, 3 1000. Ready?
1 1000, 2 1000, 3 1000.
All right, so I'm pinching the neck of the balloon. You can see that dots A and B are here, and dot C is over here. All right, now we need to record the amount of time that we blew into the balloon, which was 3 seconds, okay? Now, we need to measure the distances between, all right, so step 3, use the string and ruler to measure the distance between A and B and between C and B. So I'm going to make sure that I'm going to move this up just a little bit, put my ruler here, okay? So what I would do first, and you can use 2 people to do this. It makes it easier if one person runs the string and the other person holds the balloon, okay? I'm going to give you a demonstration with only one person. So I'm going to put the string on A, and I'm going to use my fingernail to mark where B is. So the end of the string is A, my fingernail is B, okay? So I will then come down here and measure, okay? I'm not going to give you the measurement because I want you to come up with the measurement on your own. So we're going to put X centimeters is the distance between A and B, okay? Now I'm going to take the string and I'm going to find the distance between B and C. So I would place the end of the string on B. I would follow this over, place my fingernail where the string meets C, and I would then figure out about how long or how much the distance is in centimeters between C and B. We'll call that distance Y. So Y centimeters would be the distance between C and B. All right, step 4. calculate the rate of change in the distance between A and B and between C and B. To calculate the rate, subtract the original starting distance between the dots from the distance measured after inflation. Divide this number by the number of seconds you blew into the balloon. Show your work by setting up the equation and writing the answer. Your answer should include 2 units, time and distance. So we would need to take A and B, all right, so we know that the new distance between A and B is x centimeters minus the original distance. The original distance is 1/2 centimeter minus 0.5 centimeters equals, okay? All right, that will give you, we'll say, answer F. All right, you must divide F by 3 seconds. And that will give you your rate of expansion. And your units will be centimeters per second. Okay? So that's how you would set up that equation. You need to show your work. All right, next one. You would take y centimeters minus its original distance, which is 5 centimeters. 5 centimeters equals g divided by 3 seconds, which will then give you a different rate of expansion in centimeters per second. Okay? So then you'll be able to compare the rate of expansion between A and B, and you'll be able to compare the rate of expansion between C and B. Once you're done with that, you will turn the paper over. Okay? So this is what the back side of the paper looks like over here. All right, 5th step. With the balloon still inflated, from step 2, blow into the balloon for an additional 2 to 3 seconds. All right? So, Michael, if you will, again, count to 3, 1,003. All right, ready?
1 1,000, 2 1,000, 3 1,000.
All right, nice. So again, we blew into the balloon for 3 seconds. Now, step 6 is very much like step 4. Okay? The only thing is, you're going to use your rate of expansion here, or excuse me, your distance. All right, so all right. So measure and calculate the rate of change in the distance between A and B, and between B and C. To calculate the rate, use the distance measured in step 3 as the original distance. Show your work and include your units. Okay? All right. So what we would do here is we have a new set of distances. So we would take, again, we would measure. Now, we measure again. So we have a new distance between A and B. We would measure this. So A and B have gotten further apart. So there is a new measurement here. We write that measurement down. So they say they're h centimeters apart. Okay? And we would subtract that. We would subtract that from our old measurement, which is x centimeters. And that will give us a new number. We'll call it j. Okay? J centimeters divided by 3 seconds will give us a new rate of expansion in centimeters per second. Okay? All right. Now what we will do is we will need to measure the distance between B and C. B and C have now gotten further apart. So we're going to want to, again, this is much more easily done with 2 people. We're going to want to measure the distance between B and C without putting too much pressure on the balloon. All right. We would then compare that new distance to our ruler here. Okay. Once we identify that new distance, we'll call that new distance I. So I centimeters minus y centimeters equals L centimeters divided by 3 seconds gives us a new rate of expansion. Okay? All right, so we are now done with measuring our universe, all right? And we would compare. So take a look over your information. Now we'll move on to the analysis and conclusion. So what it's asking you here, did the distance between A and B or between B and C show the greatest rate of change? So it's asking you, did the distance between A and B or did the distance between B and C show the greatest rate of change? All right, so you'll write your answer in number 1. Number 2, did the rate of change for either set of dots differ in steps 4 and 6? Explain how it changed. So this is step 4 over here. This is step 6 right here. You need to analyze and compare your rate of expansion here, and you need to analyze and compare your rate of expansion here, especially between C and B here, and between C and B there, between A and B here, and between A and B there, and analyze which one showed a rate of change and how. All right, finally, step 3. So, suppose dots C and A represent galaxies and dot B represents the Earth. How does the distance between the galaxies and Earth relate to the rate at which they are moving apart? So, if if Earth is B, if this is Earth, it's asking you, is A moving away faster or is C moving away faster? All right, so rate of change. This is Earth. This is a galaxy. This is a galaxy. Which one, A or C, is moving away faster? Okay, so you will then answer that question in the space provided. All right, so thank you for being part of our small scale investigation, and that's it.